calculus. Today we are going to do the same thing, but we're going to rotate around vertical axes, which means we will need horizontal rectangles in order to be able to make those discs or washers. Okay? I want you to notice how our rectangles have to be perpendicular to the axis of rotation so that when we rotate them, we get that disc or washer figure. Okay? So, we are going to do the same thing, except when we rotate around a vertical axis of rotation, we have to have horizontal rectangles with thickness dy. So, our equations need to be equations in terms of y. Okay, and we've already practiced that with the area, right? If we have a horizontal rectangle, we know that it has thickness dy, so our equations need to be in terms of y. Sometimes they will be given to you in terms of y, but sometimes we have to solve for x. Okay, it just depends on the problem. All right, so same thing, we still have pi r squared minus r squared h. This time h is dy. We still have to take into account how far our rectangles are from our axis of rotation to get our outer and inner radius. Also keep in mind that since we are integrating with respect to y, our limits of integration will need to match. So those need to be in terms of y as well. Yes?
Are they equal to, like, the x equivalents? So, like, if you had if it was about the y-axis, would it be the same if it was about the x-axis?
Not always.
Not always.
Because we're going to get different shapes, right? And so there will be some shapes where, yes, we'll get the same volume, and some shapes we will not. So it depends. Like if we have like square root of x and like y equals x squared, kind of like that teardrop, we would get the same thing because we have some symmetry there, but not always. Okay. All right, so I have 3 examples for you on this lovely Wednesday morning. Here's our first. Okay, so the things that you need to write down. We have the region bounded by y equals 2x squared, y equals 0, x equals 2, and we're rotating about the y-axis. All right, so y equals 0 is the x-axis. Y equals 2x squared is a parabola, and then x equals 2 is a vertical line. So really, we are worried about this region right here, because that's what's bounded. I'm going to go ahead and erase the other half of the parabola. It really doesn't matter. Since we are rotating about the y-axis, we are now going to have to draw horizontal rectangles with thickness dy, and I want everybody to look at that rectangle and imagine it rotating around the y-axis, and I want you to visualize the one washer that rectangle would make. All right, Grant's got it down. All right. If you need a visual of what's happening, kind of, yeah. It would be like a cylinder where you'd have like this parabola skate park type shape inside, right? So first of all, I need to know what this coordinate is right here. We know that x is 2. What's what?
2, 8.
2, 8?
Maybe.
Yes, you agree?
Oh, wow.
Great. Okay, so that's the coordinate 2, 8. Why is that important? When we find our area, pi r squared minus r squared h, our limits of integration now need to be in terms of y. So we need to look at the height. This region begins at 0 and stops at y equals 8. So 0 to 8 are our limits of integration now.
Do we do right to left now? Or left to
Yes.
right?
Right minus left. Okay, so just like yesterday, how I made you focus on top minus bottom, now we have to readjust our focus to right minus left. Okay? So our outer radius, okay, so we're rotating about the y-axis. We have a radius from axis of rotation to the right of the rectangle, axis of rotation to the left of the rectangle. Which one is bigger? One to the right, okay? So the right of the rectangle sits on the function x equals 2. So we have 2 minus 0 squared. That's our outer radius. Okay. Now, we have an issue. Is that a function written in terms of y? It is not. So we need to do a little bit of work, okay? We have y over 2 equals x squared, which means x is plus or minus radical y over 2. This piece of the parabola, is it the positive or the negative side? It's the positive because it's on the positive side of the x's, right? Okay. So this is actually the curve x equals positive radical y over 2. So when we talk about our inner radius squared, we have radical y over 2 is our inner radius squared. Okay. Is this one that I would make you do by hand or with a calculator? What would you think? This is one that can be done by hand without too much trouble. Why, Cole? Look. You have 4 minus y squared over 4. I'm glad you can see my pose. Okay.
It would just be y over 2.
Yeah.
Oh, thank you, thank you. I got excited. That's why I pay attention. Okay? All right. This is like a piece of cake, right? Our antiderivative is 4y minus y squared over 4. Evaluated from 0 to 8. So let's see, we have pi times 8 times 4 is 32 minus 8 squared over 4 is
16.
and then minus 0, right? So 16 pi. Pi. Some of you were there before me anyway. The only difference from yesterday to today is we obviously have horizontal rectangles, but we need to focus on right minus left instead of top minus bottom. Also, with these examples, you'll find we'll have to do a little bit more rewriting with our equations because we typically see functions in terms of x. And so that is sometimes one extra step that you will have. Not always, but sometimes. And all of our examples today, they will. Okay, all right, another one. Okay, y equals x squared, y equals radical x. That's our figure right there, right? This is y equals radical x, and this is y equals x squared. Do you agree? Okay. Now, since we know right now that we are rotating around the y-axis with these horizontal rectangles, thickness dy, we need to rewrite our equations, don't we?
Yeah.
All right. How could we rewrite y equals radical x? Okay, this instead is going to be x equals y squared. How about y equals x squared?
Radical y equals x.
Now, technically it would be plus or minus, but since we have the positive side of the parabola, it would be the positive radical y. Okay, so now we have, here's our axis of rotation. All right, if you want to imagine what's happening, we kind of have this like flower almost. Right? We have a radius that stretches from axis of rotation to the right of the rectangle, axis of rotation to the left of the rectangle. Which one is bigger?
Y equals x squared. X equals y.
This one's bigger right here, right?
Yeah.
Okay. So we have pi r squared minus r squared h. So our outer radius stretches here to here, right minus left. We have the curve, radical y, to the y-axis 0. So radical y is our outer radius. Okay. Our smaller radius stretches from the y-axis to the curve y squared. So our inner radius is y squared. Jake, what are our limits of integration?
0 to 1.
Do you agree with Jake?
I do.
Okay, 0 to 1.
But we need a calculator to explain.
What do you think? Is this one I would make you do with a calculator or by hand?
Probably by hand.
This is one that you could have on the non-calculator part of a quiz or test, okay? Because it would not be bad at all. You essentially have the integral y minus y to the fourth, right? So Michael, what's our antiderivative?
1/2 y squared minus 1/5 y over 5.
Good. Evaluated from 0 to 1 means we have pi times 1/2 minus 1/5 minus 0. What is that? 3/10? 3/10 pi. Which, Austin, this would be the same, like if we rotated this around the x-axis, it'd basically be the same setup.
Because oh, when it has symmetry of y equals x.
All right. So those are kind of boring because we rotated around the y-axis, right? Let's do an example where we rotate around a different vertical line, okay? We're going to use the same figure, except now we're going to rotate around x equals 10, okay? So go ahead, write down, if you want to write down a new set of information, that's fine. We are going to draw a new picture for sure, okay? So we have y equals x squared, y equals radical x, and we're rotating around the line x equals 10. Okay, so I'm going to draw our same picture. Remember, this right here is y equals radical x, which we now call x equals y squared. This is our parabola, y equals x squared, so we're going to have to write it as x equals positive radical y. Okay, this would be a time where I think it's very important to label your curves. They look the same, don't they? It's not like one's a line and one's a parabola to where it's obvious. They both have a similar shape. And so as to not get confused about which one is which, you label them so you have an idea of which one you're working with. Okay, and then we have the line x equals 10 that we're rotating around. Okay, that picture might not be drawn perfectly to scale, but I do need some room to do our work, right? So, since we're making discs or washers, we need a horizontal rectangle to rotate around that vertical axis to make a washer. Everyone look at that rectangle and imagine it rotating around x equals 10, and we have these really big washers, right? Okay. So when we set up our volume, we need a radius from axis of rotation to the left of the rectangle and axis of rotation to the right of the rectangle. Which one's bigger?
Y squared.
Okay, the one with the left of the rectangle, correct? Now, so pi r squared minus r squared h. Okay, this is our biggest radius, and remember we always have to take right minus left. So since our axis of rotation is on the right, it has to come first, and then we could subtract y squared for our radius. Our inner radius stretches from radical y to x equals 10. Once again, 10 is on the right, it has to come first. 10 minus radical y, the quantity squared. Okay? I really encourage you this chapter to not just check your answers, but go to Calc Chat and check your setup as well. Okay? Because even if you have y squared minus 10, you're probably going to get the same answer, but you're not going to get full credit because it's set up incorrectly. Okay? This is one I would have you do with your calculator. So let's go ahead and practice putting it in our calculator. Now this one, since we have that radical y, I'm a little nervous about whether it's going to turn into a decimal for us or not. Or a fraction, excuse me.
Yeah, it doesn't.
I didn't think it does. Okay, so it's going to be an irrational number. It's not going to change to a fraction, so you need to multiply it by pi at the end to get the full decimal. What do you get, Logan, when you multiply pi?
Sorry, I just put pi on. It's 20.001.
With the pi? This is what Logan gets. Do you agree? Okay. We have 10 minutes of class. I need everybody to get their gold sheet out. And I'm going to tell you which ones I need you to do by hand. The rest you can use your calculator to integrate, so it won't take forever to do your homework. Okay. So by hand, and I know some of these are underlined and some of them are not, but by hand, I want you to do 7, 8, 9, and 31 by hand. 7, 8, 9, 31. Okay, so before you leave, you need to at least